everyone, my name is Navin Yadav and I am faculty of physics at Rao Public School. Now in today's video we are going to learn about Newton's law of motion. Newton's law of motion. Now in this chapter, one important thing is first law, that is defining the inertia. Okay, the first law says that first law of the motion, that is Newton's first law of motion, says that a body at rest will remain at rest, or a body in the motion will remain in motion until and unless an external force is applied over the object, okay, over the body. That means, let's suppose we are having a body of particular mass, and if it does not apply any external force, then if the object is moving, then it keeps on moving, and if the object is at rest, then it will remain at rest until and unless we are applying a force over it. Okay, now the important thing in the first law, that is inertia. First law is also known as law of inertia. What this inertia is? Inertia is the property of the object by virtue of it they resist any change. Resist any change means if the object is at rest, then it does not want to come into the motion. It will resist the change. Rest say change means. Now this inertia is of three types. Inertia of rest, inertia of motion, and inertia of direction. Now these are the basic terms. We know about all these things. Inertia of rest. Object at rest wants to be at rest. It does not want to change its shape, its position without any external position of rest. Now inertia of motion. Object in motion does not want to change the state of motion. The object does not come into rest without any external force. Now important thing, that is the third one, that is inertia of direction. Object in a particular direction keeps on into the same direction, and object does not want to change their direction. And if you want to change the direction, then you have to apply an external force over the object. Okay. Now examples of these things. The very basic example, or we have studied in the 9th class as well. Inertia of rest. We did with this an activity. We are having a glass, okay, and a cardboard was placed over the glass, over which a coin was there. Now, when we hit that cardboard with a very much force with our finger, then what will happen? This cardboard comes into the motion, and this coin goes down into this glass. That is the example of inertia of rest. Or we are sitting in the bus, okay, bus is moving with a particular speed. Then what happens? We are at rest. That means a whole position, whole body of ours is in contact with the seat on which we are sitting. A driver suddenly applies brake. Then what happens? The body which was at rest suddenly comes into the motion. The lower portion of the bus, that body, will remains on the rest condition, and the upper portion comes in the motion. Okay, the same example we can give for the inertia of motion as well. We are sitting in the bus is moving, or maybe stop suddenly, driver accelerates the bus or stops the bus. Then what happens? We fall down frontward or backward. Okay, that is because of inertia of rest and inertia of motion. Now the third one is the inertia of direction. Now we are playing football. Okay, ball is coming to us. We want to send the ball into the different direction. Then what we used to do? We used to kick that ball in that particular direction. Okay, the object, that is that ball, will remain into the same direction until and unless an object or a player is applying any force by kicking it or by hitting it with some object. Okay, so these are the inertias that we have studied in the first law. The first law is also known as law of inertia. Okay, now let us discuss something about the second law. Second law of motion. Now, let's suppose we are having an object. That object is having a particular mass m. If we applied a force over this object, then this object will attain a certain velocity. Okay, how much velocity it will gain, that depends upon the force that we have applied. And we can say that when object starts moving or it is changing its velocity, then what is happening? Momentum of the object is changing. Momentum is what? That is the product of mass and velocity. Okay, this is momentum, the product of mass and velocity. Now second law is saying that force produced or the force applied over the object is directly proportional to rate of change of momentum. Okay, that is F is directly proportional to dP divided by dt. This is rate of change of momentum. Now, if we remove this proportionality sign, then we get a constant, that is F is equals to K dP divided by dt. Okay, now further substitute value of P, that is F is equals to K dmv divided by dt. M is constant, so take it out common. It is dv divided by dt. Okay, now this term dv by dt is what? Rate of change of velocity, or we used to call it as dv by dt as acceleration. Okay, so we can write it as F is equals to K m a, where the value of this K depends upon the unit system or unit that we are going to use. In SI unit system and in CGS unit system, the value of K is equals to 1. Okay, now let us discuss something about its dimensional formula of force. Dimensional formula of force is M L T minus 2. Okay, that we learned in the chapter number 2, how to find the dimensional formula of force, or we can say that it is mass into acceleration. Dimensional formula of mass is multiplied with dimensional formula of acceleration. Then we can calculate dimensional formula of force. Okay, now this is quite important, that is the units of the force. Units. Now in SI and in CGS both, SI units में force is Newton, or we can say it is kg meter per second square. That is the SI unit of force. Now in CGS, force is dyne, dyne, or it is gram centimeter per second square. These two are the absolute unit of force. The relation between Newton and dyne is 1 Newton is equals to 10 raised to power 5 dyne. This is the relation between, that means 1 Newton contains 10 raised to power 5 dynes. Now these two are the absolute unit of the force. Absolute units of the force. Gravitational unit, these are some different units. Gravitational units. In SI it is kg force or kg weight, and in CGS it is gram force or gram weight. Okay, 1 kg force is equals to 9.8 Newton and 1 gram force is equals to 980 time. These are the gravitational units of the force. That means 1 kgf, that is the gravitational unit of force, it is equivalent to 9.8 Newton. And in CGS, 1 gram force is equals to 980 Dye. Okay, so in the next video we will be learning about the other concepts of the Newton's law of motion. So thank you very much.